Lists are great in Python. They're very easy to use. So why don't we use them for data science? So let's have a look at the list against the numpy array. So the numpy array uses less storage, has faster access, and operations on the items in a numpy array are faster. How? Well, we have faster memory lookups and faster in cache. So what does that mean? Well, to start off with, the numpy array has a fixed type, only uses 4 bytes, where a list uses 28 bytes. So let's explain why that is the case. So here we have an integer, a number, and it's using 4 bytes, int32. So in a numpy array, we're just using 4 bytes, 32 bits for a simple number. We could specify less size if we knew the number was just 1 digit, for example. But in this example, we're using int32. So numpy array, 1 number, 4 bytes. Now, an integer in a list uses the built-in integer type in Python, and that has 4 parts: size, reference count, object type, and object value. And these have the byte sizes of 4, 8, 8, and 8, that total to 28. So an integer in a list consists of these 4 parts: size, reference count, object type, object value. So this is how Python uses the integer in a list. We compare that with the numpy integer, and you can see that it's a lot smaller in a numpy array. Type checking. In a numpy array, everything's the same type, so we know what it is. In a list, we can use different types, which can be handy, but not faster. So when we use items in a list, we need to check the type. Also, how they're stored. NumPy has all the items stored together. In a list, we use pointers to the items. If you can remember, we showed how a list stores the different items. So here's an example of a list that uses different data types. We've got an integer, we've got a tuple, we've got another list, we've got a string, we've got other numbers. Now that's what we think's in a list, but actually they're not really in the list, they're stored in memory, and the list uses pointers to those values in the memory. So they're not really stored together, they're stored in different places. So here's a graphical example of the Python list with the items and the pointer to these items in memory. Whereas the numpy array, we just simply have the items in order. So much easier to access, for example. Now we're looking at bytes. In the storage, with an empty list, we've got x equals empty list and y equals the numpy array. And you can see when they're empty, the numpy array takes up more room. Not too much bigger, but just a little bit bigger. Once we start putting data inside, all of a sudden the list is bigger than the array. Again, x here has 100 elements, y has 100 elements, but it's an NPN array. Now what happens if we have a lot of data? So here we've got numbers 1 to 1,000,000. You can see there's a huge saving using a numpy array in bits over the Python list. X is the list, y is the numpy array, and it uses a lot less memory when it's stored. Not only this, with the continuous or contiguous memory, the single instruction multiple data, SIMD, can be used, which means that we can apply operations on more than one item at a time. Now this is very useful for things like vector processing. So imagine you had 10 numbers. Instead of multiplying each one as in a list, you'd use a loop. With this SIMD, you could then say multiply each number or add a number to each 10. So you can perform operations much faster with this approach. But you need each item to be next to each other in memory to be able to apply it. So we can do that with this numpy array. What about pandas, the series and data frames? Well, data frames are really like tables, so they're multi-dimensional. Series are the columns in the data frames, if you like. So a series is a bit more like an array. We use the series like a column in the data frame, so we can think of that as more one-dimensional, whereas a numpy array we can use for more than the one-dimension use. We can apply different functions on the series as we can on the data frame. So when we look at the memory, the series is very similar to the numpy array. So the numpy array and the pandas series are quite similar when it comes to the amount of bits that we use when it's stored. Data frames, multi-dimensional, we're used to seeing them in like a table, so they're more like a nested array or list rather than a single one. And as I said, we can apply functions on them. Now, there are other types of ways we can store data, especially huge quantities of data that perhaps a data frame is not capable of storing. So for example, if we have over 8 GB, we might think about storing the data in a different type, different form. So there are other types or other formats that we can use to store data. Perhaps that may be an X series. Okay, if you enjoyed that, please give us a like, and if you haven't already, subscribe, click the notification bell, and then when a new video gets released, then you'll be notified.